Hello, let's talk about 3D printing. Why the hype? Is it a fad or a true disruption? And why is it considered an exponential technology? 3D printing is any process that allows us to print, join and solidify matter to create physical three-dimensional objects based on digital files with computer control. But for some time the technology has been a little beyond the expectations, because it was slow, valid only for low detail and small objects, and the range of possibilities regarding materials was very limited. It was in what we call the deceptive phase of the technology, promising but not yet there. But that was the past. Now buckle up, because we've hit a point in the evolution of 3D printing where everything starts to change really fast, exponentially fast. And if you blink, you'll miss it. Let's see some of the milestones on the evolution of this technology. It all started in the 80s with a technology called the stereolithography, invented by Chuck Hall, co-founder of the 3D Systems. Today, this is the most commonly sold 3D printer. It's a desktop 3D printer called the Material Extrusion Filament Based 3D printer. It uses a plastic filament and it's sold for well under $500 today. I've personally used it to print coffee cups and key rings, and you would think key rings wouldn't take the tech very far, but during 2017 500,000 3D printers were sold. That is a lot of 3D printers, but experts believe we will be selling north of 100 million in 2030. Speaking about exponential growth. 3D printers are also called additive manufacturing, and they've come a long way in recent years. Today, there are up to 7 different technologies with different feedstock and binding mechanisms used across industries for 3D printing all kinds of materials. I've used the fused deposit modeling FDM to create a 2 by 2 feet sleek model resin model of this building that helped me land the sale. The machine required for this is a little larger and a little more expensive, around 100K, but they also give you smoother finishes, strong materials and high speed and precision. But not only can you create models with 3D printing, the model might be the final product, just like this molten steel pedestrian bridge built in Amsterdam. Some engineers are using this technology, these very technologies, to print fully functional electric cars. This is an example of a 3D printed car on sale in 2019 for under 10K. Everything but the tires, the windows and the chassis is 3D printed here, in a record time of just 3 days. In China, 10 completely 3D printed houses appear in Shanghai in 2014. They were built under a day. And if you don't like this house, you can always get this other one a little more classical. It was 3D printed too, in some 40 days. It's a record time with almost no human intervention. But wait, there is more. General Electric has patented a 3D spraying technology that sprays metal powders at high velocities to build part or repair any existing part. Today, there are at least 2 3D printers living in the International Space Station from a Singularity University startup called Made in Space. But why does NASA need 3D printers on the space station in the first place? Well, it has mostly to do with the amount of time and money that it takes to send something into space. According to NASA, it costs roughly $10,000 to send just 1 pound of payload into orbit. So we're talking now about on-premise customization of supplies. But now, look at this other technology. It's called the clip. The continuous liquid interface production, and I believe it's the coolest 3D printing technology ever. Clip uses photopolymerization to create smooth-sided solid objects of any variety of shape. This is the closest you can get to magic. You can print your clothes, you can print your sneakers, you can print your drones, you can even print human tissue for organs and transplants. The point I'm trying to make here is that these technologies are no longer on the infancy. They are mature technologies with real-world applications. Now, companies as Lockheed Martin, Airbus, Ford and Rolls-Royce are among the early adopters of 3D printing technologies. So why is that? Why are they adopting 3D printing? Well, For once, 3D printing is giving superpowers, prototyping superpowers to designers and engineers. Now we no longer need casts or mold, so the costs of prototyping are dropping exponentially. These technologies are also getting good and precise, and now they're using it to manufacture critical parts of engines. And complexity is now free. Anything can be now 3D printed, no matter how complex you want to create it. That is opening the door to a completely new way of designing and manufacturing, and companies such as Airbus are saving millions of dollars thanks to newly designed and manufactured internal partitions in their A320 airplanes. Airbus is saving 15% of the material weight to the 3D printing technologies. And scale is no longer a limiting factor. This is a 3D printed chassis of a car, but Airbus is exploring a full-scale 3D printing airplane. And if that's not enough, you can mount 3D printers or drones to 3D print anything, anywhere, at any scale. Why all this matters? 3D printing is changing the manufacturing and supply chain industries at once. Now additive manufacturing allows for an on-field, on-premise customization of supplies. And you can produce things yourselves, you diminish the need for factories. Inventory becomes less necessary, and so does transportation. Why ship something when you can produce it locally? Now, what are the next steps into the 3D printing technology? There are research groups working on the idea of the lab in a box for combining both additive and subtractive manufacturing technologies. Other researchers are exploring the idea of the multi-material printing. And then we have the 4D printing, the printing material with a shape memory, which will morph depending on electrical impulses or temperature, etc. Other people are exploring the possibility of printing full electronic circuits and even printing sensors. And another line of research I could consider of particular interest is the reprintable matter, a completely recyclable, zero-waste system that allows you to repurpose and reshape the material over and over. But the real challenge of 3D printers remains to become massively adopted by the end users. In my opinion, the limit is not currently set by the 3D printing technologies, but by the designing technologies. So to unlock the abundance, the potential of the 3D printing, we will need to lower the barrier of entry, not on the 3D printing technology, but on the design technologies, to democratize design of the 3D models. Happily, there are new technologies that allow just for that. They're called parametric, generative design, evolutive design, and they're bringing some AI to the process of design. That will not only make the design accessible to everyone, but most likely will be disrupting us designers, architects, and engineers. But we will cover that in some other videos soon. Now, thank you so much for watching. This was Diego Soroa, and stay tuned for more videos on exponential technologies and exponential organizations. Printed pizza, anyone?